Not everyone dreams of falling in love. Instead, some might dream of falling inside a black hole. Undoubtedly, black holes are some of the most mysterious objects in the known universe. Almost every galaxy contains a supermassive black hole, up to billions of times more massive than the Sun. Even the monstrous stars in the universe end up becoming a black hole, a region of space-time so dense that even light cannot escape it. But an exciting question that often comes to our minds is, what would you see if you fell into a black hole? Would you enter a parallel universe with different laws of physics? Or would you be flushed out to a different part of our own universe? Most importantly, how will time behave inside a black hole? Would you be able to see the future of the cosmos? The questions are endless, and here are the answers to some of these. Recent gravitational wave observations have shown that not all black holes are alike. Instead, the universe is littered with a vast zoo of different types of black holes, and a trip to each of them would be an entirely different experience. However, one thing is common in every black hole: the event horizon, an invisible boundary considered to be the point of no return. If anything crosses this invisible boundary, it diminishes into the vastness of the black hole forever. The radial size of the event horizon depends on the mass of the respective black hole. For example, the event horizon lies closer to the center for a stellar mass black hole than a supermassive black hole. So, if you choose to go inside a stellar mass black hole, you'd be much closer to the singularity or the center of the black hole. Now, something weird will begin to happen there. As you get closer to the black hole's center, its pull on your body will differ by a factor of 1 trillion times between your head and toe. In simple words, if you are falling with your feet towards the center, the gravitational pull on your feet will be exponentially larger compared to the black hole's tug on your head. You don't feel the same on Earth because the gravity isn't that strong. The difference in gravitational pull would stretch you like a noodle if you were made of rubber. But since that's not the case, the black hole's pull will instead snap you multiple times till every single atom of yours becomes an unrecognizable parade of particles, a process scientifically called spaghettification. So yes, you would be as dead hundreds of miles even before you hit the singularity. But the scenario would be quite different in the case of a supermassive black hole. Let's consider the case of the black hole present at the heart of the Milky Way. Its mass is about 4.5 million solar masses, and hence its event horizon lies much further away from the center, at 17 solar radii, or about 12 million kilometers. Hence, if you fell into a supermassive black hole, you would reach the event horizon much farther from the source of gravitational pull. Furthermore, the difference in the gravitational pull between your head and toes would be nearly zero, giving you a chance to pass through the event horizon unaffected. But this doesn't mean that you start packing your bags to visit these giants. Even a trip to supermassive black holes would be a one-way affair. It's just that you would survive comparatively longer here. Moreover, as you get closer to a black hole, the flow of time slows down. So you're thinking, how is it possible? Well, before Albert Einstein, scientists believed that space and time were absolute. Time is the same everywhere in the universe, no matter where it is measured. But Einstein's theory of relativity showed that time isn't absolute. Instead, it's relative and slows down around massive objects. Even the Earth produces this effect, but Earth's gravity is so weak that the slowing of time is not noticeable. However, the effect has been confirmed using sensitive instruments. For example, you age 1/billionth of a second less every year at sea level than you would if you lived on top of Mount Everest. Now coming back to a black hole, the slowing down of time is much more extreme there. So if an observer is viewing you from far away because of gravitational time dilation, you'd appear to slow down as you approach the event horizon. Also, you'll start appearing red because of the tremendous redshift. Finally, the moment you reach the event horizon, you'll appear frozen in time, but you wouldn't notice any difference at the event horizon. Time will run as usual around you, and you'll pass the event horizon without any anomaly. Even after you pass the horizon, the outside observer will see you frozen near the boundary. To them, it might seem that the story is ended. However, the most exciting region lies inside the center of the black hole, the singularity. It's a place where all the known laws of physics break down. For example, Einstein's theory predicts that time itself is destroyed at the center of the hole, and no one knows how or why time could come to an abrupt end. Nevertheless, we don't even know how time was created in the first place itself. Everything about what lies at the center of a black hole is mysterious. It might provide a route to a parallel universe, or an opening to the throat of a wormhole. But no matter what type of black hole you fall into, you're ultimately going to get torn apart by the extreme gravity. Once you pass beyond the edge of the event horizon, you are done. There's no getting out, and you would never be able to report back what you saw there. So would you still fall in love or into a black hole? Share this video with your friends and follow our Facebook page for more.